Okay, well, start again here. Good morning, everybody. We're going to be wrapping up chapter 5 and 6 today. We have our test coming up on Tuesday, and we're going to do a little activity on confidence intervals for a population proportion. That's our plan today, or at least I'm going to get you started so that you can work on it on your own. So the first thing I would like to do is share with you my screen so that you can see the calendar. So here we are in our class. So here's what we've got going on for the next little while. Today we're wrapping up 5 and 6. We're going to do this Hershey's Kiss activity, and at least get started on it. On Tuesday of next week, we're going to be taking the chapter 5-6 test. And I'll talk a little bit about that in just a second. And then we're going to start chapter 7, hypothesis testing. I know that we had planned to go through chapter 10, but I don't think we're going to get quite that far. Chapters 7 and 8 are both on hypothesis testing. And I think maybe one chapter of hypothesis testing might be enough. We'll see how far we get. But we're going to start on chapter 7 and do parts of 7 and parts of 8. We definitely want to take a look at chapter 9, and I have a feeling that that might be it. So we're going to take this chapter 5-6 test, and then it's likely that we're going to take a chapter 7-9 test, and that'll be our last exam. So that's what I'm thinking right at this moment, but I will certainly post here on the homepage in Canvas as soon as we make some decisions about where we're going, and you can be kept up to date and know what's going on. I will also send you some announcements from time to time about what's going on. And recently, right, I sent you this one that was about next week. So here's some more information about next week. We're going to be taking this third test. Okay, and this time it's going to be in Canvas. So you'll find it as under the modules. So if you go to modules, down here under activities, which is a new category, you're going to find today's activity that we're talking about and the chapter 5-6 test. I don't know exactly what it says on yours, but it won't be available to start until Tuesday morning. I'm going to make it available at 8:30 in the morning, and so right when class starts. And then this time around, you're going to have all the way until midnight, so you'll have all day to get that done. For the last test, we're going to change things up a bit, and for the last test, since it's sort of our final exam, there's some concern in the math department about making sure that we're doing some proctoring. So I'm going to need you on the last test to connect to the Zoom meeting and be available with your video so that I can watch you finish up that last test. The last test is also going to be just a regular time test. So this will be our practice run on the 5-6 test. And then the last test, our final exam, it will be a regular proctored 2-hour final, and it'll be during the regular time when the final was scheduled. So I think that was for you guys maybe on Monday. But again, I'll post some more information when we get a little closer. So sometime on Tuesday, you're going to click here on the chapter 5-6 test, and then it's a series of multiple choice questions. You can answer them. Some are multiple select, some are multiple choice. And at the end, I have an open question for you to upload any supporting written sort of notes that you have or calculations that you have to support your answers. So what you'll do is you'll take a picture of your notes using your phone and create a PDF, and then submit the PDF to me at the end of the test, and I'd be happy to look at your written work for partial credit on the to sort of support your multiple choice selections. So that's how the chapter 5-6 test is going to go. And we're going to give that a dry run. We're going to give that a try, make sure everything's sort of working well on Tuesday. I made it all day so that if we do run into problems, especially if it's individual problems, that I'll be around to support you and make sure we can get that done. And then when we get to the final exam, hopefully we won't have any problems. Okay, so there's the test for next week. You'll also notice that I've been adding the recordings for the class down here. And if we did any handwritten notes, I've been trying to add them in here as well. So chapter 7 notes will be coming as soon as I get a chance to get them done. I'm thinking probably this weekend sometime. So you should be looking for the chapter 7 notes coming up. And that's about it for modules. So there's the announcements. Questions about the test or what the activity or what the calendar looks like? Let's see, can I see? I can't see the chat. Where is the chat? I don't know where the chat is when I'm in this mode. Oh, there it is. Maybe that's it. Okay. No. Okay, good. What about the amount of time? On this test, on Tuesday, you have no time limit. So, well, technically you have all day, okay? You have till midnight. So I'm gonna open at 8:30 in the morning and it'll be due at midnight. So lots and lots of time. For the final exam, we're gonna use the final exam schedule. So it's gonna be a 2-hour test. But you'll have had a chance to practice on this one and make sure everything's gonna go smoothly. Other questions? Okay, well, seeing none, if you think of some, you can certainly write them in the chat or turn your mic on and ask me, or send me an email if you don't think of one here while we're talking today. Okay, so here's the next thing I sent you. Let's go back to the calendar. Here's the calendar. So hypothesis testing, as I said, and then I'll get some more things posted here on the list. I think that takes us to today's activity, which is going to be looking at a population proportion, a confidence interval for a population proportion. And we're going to do a little experiment using Hershey's Kisses. Before I get to that, though, I wanted to make sure that you were feeling prepared for the test and wanted to ask if you had any questions. I'm going to stop sharing that. Okay, any questions about chapter 5 or 6 that you would like me to do, either from the homework or ones that you've been thinking about or stuck on? Anything you want to see from chapter 5 or 6? The final test, same amount of questions. Yes, I would say that it looks like about 25 questions. I will grade them like 2 points apiece, like I did before. And what I'll do is, if you get it right, then I will just go on about going down to the next one. If you get it wrong and you submitted some supporting, work, I will look at your work, and if you're on the right track but just didn't quite get the right answer, then I'll give you some partial credit. But the test will be about the same length. It was designed so that you could have taken it in a regular class period. And it'll be about 25 questions, or 25 sort of mix of multiple choice and multiple select questions. Okay, well, I'm not seeing any questions. I would be happy if you get stuck as you're studying and finishing up the homework in my stat lab to answer questions on the email if you run into some. So be sure that you send me a note if you're having some trouble wrapping things up. Officially, I made everything due at the end of the semester. So all of my stat lab assignments aren't due until May. but I would strongly recommend that you try to finish up as much as you can before you take the test. Okay, so try to use this weekend to wrap up these 2 sections, and then that should help you do a little bit better on the exam, and it won't let things pile up until the end of the semester. Yeah, I can. Juan asked for a recap of chapter 5. So chapter 5, let's see if we can go back here and find some chapter 5. Of course, in the book or in my stat lab, there's going to be sort of a review section and some extra problems for you to look at. There's also a chapter quiz where you can practice a little bit. And then some review exercises. So you could take a look at this review materials that are in your book. That might help a little bit. But here's the recap real quick on, I'm gonna make it a little bit smaller. It's hard to read, but I'll kind of read out loud for you. Okay, so here's the recap. Chapter 5 was about probability distributions. So we said we wanted to take a look at a normal curve, right, to approximate a histogram that we had built from data. And we said that if the data was normally distributed, if it's mound-shaped and symmetric, then we can approximate the distribution using a nice smooth curve called a normal curve. And the reason that we did that is because it's easier to find the area under the curve than it is to sort of add up all the data, especially in the binomial distribution. So then we spent a little bit of time looking at how to find the area under the curve. Right? And we drew some pictures of it in Desmos and looked at some different ways that we could calculate that. We found out that we can find areas under curves by using Desmos. We could use our TI-84, and we could use the table in the back of the book. Those seem to be the 3 most popular ways. You could use, you can also use StatCrunch, and you can use Google Sheets or Excel. Those all will work for you. So the idea was that the total area under the curve was 1. And that looked something like this, right? We said, okay, let's make a normal distribution. And we said, okay, it's going to be this bell-shaped symmetric curve. And it has some properties, right? The area under the curve, all the area is 1. We said there's the 68, 95, 99 rule that says the area, right, that is within 1 standard deviation of the mean would be about 68%. And if you use the, if you use the back of the book, you could get that number a little bit more accurately, but approximately 68% within 1 standard deviation. Within 2 standard deviations, right, we ended up with 95%. And within 3 standard deviations, we ended up with 99%. So something like this, yeah? Which means that if something is more than 3 standard deviations away from the mean in a normally distributed data set, it's really rare. There's only 1% of the area left hanging outside of 3 standard deviations. So given that it's symmetric, there's about 0.5% in here. So it's only 1/2 of 1%, which is the chance that it might fall over here, given that our data is normally distributed around the mean. Okay, and so we can use that information then to try to describe how unusual it might be to get one of these outlier data points. And then we looked at things like men's heights, and we said, how rare would it be to have somebody as tall as Yao Ming? And since you know, I mean, we didn't do it exactly, but Yao's probably maybe 4 standard deviations, maybe even more than 4 standard deviations above the mean. He'd be way out here, and this would be pretty unusual. In fact, I think our book has been saying anything beyond 2 standard deviations, we said, is starting to get to be pretty rare. Okay, so that was looking at normal distributions. And then in section 5.2, we wanted to figure out how to use probabilities for normally distributed variables. So we said, all right, well, we can use this curve to find the area, and the area is directly related to the probability that it falls in a given region. So the probabilities and the areas turn out to be the same thing. So if we want to find the probability of finding somebody that's taller than Yao, we would have to find somebody that's further to the right over here than Yao Ming would be. And well, since there's only 0.5% of the people bigger than 3, and Yao's already over here, it would be pretty unusual, right, that we would be able to find somebody you know, taller than that. Okay, so 5, 1, and 2, and we did a little quiz over these, right? So we did a little quiz, and some of that quiz material is still going to be there. So draw a normal curve, find the area between a couple of values. In section 5.4, which is really the new material then, we said, let's start to take a look at sampling distributions. In other words, we made a shift. We decided that what we wanted to do was approximate or estimate population parameters given a sample or a sample statistic. So we can estimate any population parameter. There are lots of them. We might talk about the mean or the median, the mode, the standard deviation, the variance. But we started out by trying to approximate the mean. So we said, I wonder, you know, what the average height of a college student might be. To do that, then, we were going to look at a sample. And so to get a point estimate, we would say, take a sample, take the average of the sample, and use the average of the sample to approximate the average of the whole population. But to do this, to get some kind of feel for how rare that might be, we needed to look at what we call the sampling distribution of the mean. So that's the distribution that we get if we took all possible samples of a given size. And so we do that and we take a look at the curve. It turns out that the sampling distribution of the mean is also normally distributed as long as the sample size is large enough. So, in fact, it's actually a little better than that. It's actually a little better than that because if the original population distribution is normally distributed, then the sampling distribution of the mean will be normally distributed. If the population wasn't normally distributed, the sampling distribution of the mean still turns out to be normally distributed as long as the sample size, right, is greater than or equal to 30. Okay, so it's going to look something like this. And the sampling distribution of the mean says all the possible samples are going to be somewhere distributed about the mean, which is the mean of the population. So the mean of a bunch of samples, in other words, the mean of a bunch of means is the mean, right? The average of a bunch of averages is the average. But it turns out that the spread of our distribution, right, the spread of our distribution is better than the spread of the population. And what happens is it gets less spread out by the square root of n. So the spread of the sampling distribution, which we call the standard error of the mean, is equal to the standard deviation of the population divided by the square root of the sample size. So check this out. As n gets bigger, then our spread, right, gets smaller because we're dividing by a bigger number. And essentially what that's saying is a larger sample is going to give us a better estimate. So the more people that we sample, the bigger the sample size, then the better the estimate that we're going to have for the mean. So in section 5.4, we started looking at this distribution and calculating some areas for the sampling distribution of the mean. Officially, section 5.4 could be with chapter 6 because it really kind of starts that conversation. Okay, so then we got to chapter 6. I'm going to go all the way back to chapter 6 here. Chapter 6 at the back. Here are some things that we looked at. We said we would like to find a point estimate for the mean of a population. So it makes the most sense that if we want to estimate the average of a population, we're going to use the average, right? We're going to use the average of the sample. And we had already studied the way that the sample means are distributed back in section 5.4. So 6.1 was more or less just putting this all together and looking at this sampling distribution of the mean and saying, I wonder what's the chance that a sample of a given size falls within a particular range or a confidence interval about the mean. And so we know that 68% or so lands between 1 standard deviation, 95 between 2, and 99 between 3. And then we said, well, you know, we don't really want it to be exact. Well, we wanted to have an exact level of confidence, either 90, 95, or 99. So as you know, the critical values, right, that cut off exactly that confidence level were like 1.96 and 2.56. And so it was pretty close, right, to 2 standard deviations for a 95% confidence interval. And so we learned how to find the critical values, and then we came up with a confidence interval around, you know, for our estimate. Okay, but the problem there in 6.1 was to figure out the spread of this sampling distribution, we needed the spread of the population. In other words, to do this calculation. And it turns out that most of the time, if we don't know the mean, then we probably don't know the standard deviation of the population either. And so in 6.2, we said, well, what if we don't know it? And the answer is, well, we're just going to put an S right there. We're going to approximate the spread of the population using the spread of a sample. Okay, and so if we do that, then we've estimated this and we've estimated this, and this introduces a lot more error. In fact, we get something that we called a student T distribution. It's more spread out, right? So this would be a T curve, right? From the student T distribution. And we looked at that in section 6.2. Right? We looked at the student T distribution in 6.2, and we said that we're going to have to use this curve instead because we're going to get additional error because we've estimated the spread of the population. The process was exactly the same, but the curve that we used was different. And so you just had to kind of work out some of the details there in 6.2 on how that all kind of plays out. And that gets us to 6.3, which is the last section that we're going to consider. 6.3 talks about how to estimate a population proportion. So so far we've been talking about approximating the mean, and now we want to talk about the approximating a proportion. A proportion would be a situation where we ask perhaps a yes or no question, like how effective was a flu shot? And we'd say, well, if you get a flu shot, then 70% of the people don't get the flu. And so how do we approximate what's happening with the whole population? We would do the same thing and we would look at a sample. So we'd say maybe give the flu shot to 1,000 people and say, out of this 1,000 people, what proportion didn't get the flu? And then we would use that sample proportion to approximate the population proportion. And we can go a little bit further and build a confidence interval for our estimate as well. And so that's what 6.3 is about. So pretty much what we're doing all in both of these chapters is we're learning how to approximate something about a population, a parameter of a population based on a sample statistic, and then giving a level of confidence and a confidence interval for our estimate. And I think that's really it for 5 and 6, right? And so I know that there's some formulas. I would say that the standard deviation formulas are the ones that you would have to take a look at, and this is kind of the big one. But I think that you should be able to remember that as the sample size gets bigger, the spread gets smaller, and what we end up doing is dividing by the square root of the sample size. Okay, so that's the recap. That was 5 and 6, and we're going to do the test on that on Tuesday. Anything else? Other questions? So as you're doing your own review and finishing up the homework problems, again, if you have specific questions for me, you can see me during office hours. You could ask me right now, or you could send me an email, and I'll try to help you work through some of those details. Okay, so here's what else I want to do today. I want to do a little experiment. So we're going to try an activity. It's a little bit messy to do because, of course, it's a group activity. And if you were doing a group activity, you'd need to be in groups, and you're all in your houses. And so we're going to try a little virtual group activity where you're going to do a little work at home, and then you're going to share your results so that you can use each other's results as part of the calculations. So to find the directions, you're going to go back to Canvas. And so I'm sharing my screen with you so you can see it. And go under modules. And right here under activities, you'll find the Hershey's Kiss activity. So, and you'll also find the Hershey's Kiss discussion board, which is where we're going to share our results so that you can get the results from your classmates and finish up the activity. All right, so here you go. Click on this. And so it gives a little description. In the activity, we're going to estimate confidence intervals for Hershey's Kisses, and we're going to toss them and see how many land on their base. So I got some Hershey's Kisses. I actually got 2 bags, but I ate one already. And so you'll have some, I don't know if you can see it. Yeah, you can see this, okay. Okay, so here's some Hershey's Kisses, and we want to know what happens, right, if I just dump out the bag, right? I shake these up and I drop them, and I want to know, what happens with this. I'm going to push them back in because a couple of them you can't see. Okay, I want to know what happens when I drop them. So this one landed on its base. This one's on its base. That's 3. There's 4. So 4 landed on the base, and 4 landed on the side. So it looked like about half and half of the 8 that I tossed. And so what we want to know is if I dropped Hershey's Kisses, all of them, right, as many times as there are, and as many Hershey's Kisses out there in the whole population, what proportion would land sitting up, and what proportion would land over on their side? So that's kind of the goal of the activity. So we're going to, here's the PDF. So you can download this PDF and print it out. Okay, and then there are some blanks for you to fill in as you do the activity. And then what I'd like you to do is submit this activity back to me. And so the way you do that is, the way you do that is hard to see on mine because I got the teacher view. But on yours, you're going to have a big blue button up here that says Submit Assignment, and you're going to click on it, and then you're going to submit your work back to me as a PDF. So there's a couple ways you can do this. The first would be to download this. So I'm going to go ahead and show you how that goes. So it'll say, do you want to save it? And I say, yeah, I want to save it. Okay, so now I've got it over here on my desktop. Maybe I could share my desktop with you instead. Stop sharing this. Start sharing the desktop. Share. Okay, so you should have my whole desktop now. So here I downloaded it over here, and then I drag this out like this and say, there's the Hershey's Kiss activity. And now if you like to write on this electronically, you could do that on your iPad with your pencil, with your Apple Pencil or something like that, or you can print this out and write on it with an actual pencil. Okay, when you're done, you're going to have filled out this whole activity with all of your answers. And then if you did it like with a pen or a pencil, you're going to need to get it back into your computer so you can send it back to me. One of the easiest ways might be just take pictures of each of the pages with your phone, and then take those pictures and drag them into a Word document so that you can print it to a PDF. Okay, and then send it back to me. If you just write on this electronically, then you can just write on this with explain everything, or I annotate, or whatever. I got a new one on my phone just the other day. And so you can write on it directly and then send it back to me electronically. Either way works just fine. Okay, so there's the activity sheet. And then we're going to need to go over to the discussion board to post our intermediate results so that you guys can finish filling this thing out. So let me get you started. I'll stop sharing that. I'm going to just share this so it's big enough we can see it. Okay, share. All right, so you'll get your own copy, and it's going to ask you to do a few things. So the first thing that it's going to ask you to do is to record the names of the people in your group. So if you were working at a table with 4 people today, you'd have those names. You're going to be able to pick anybody from the discussion group that you want, but I would like for you to pick 4 other people. Okay, so you'll have your results, and then you'll have 4 other people, and you can just pick the first 4 that respond to the discussion group, or you can pick your friends or whoever you want, okay? But you're gonna need some data from some other group members. Go ahead and make your own group. So in the activity, we're gonna estimate how often a Hershey's Kiss lands on its base, and so, and then build a confidence interval for our proportion. So the population of interest, right, would be dropping all Hershey's Kisses in the whole, in the whole world. Okay, so the population is every Hershey's Kiss that ever was. The parameter that we're trying to estimate is, we usually call that P, or the population proportion. Right? And in this case, the proportion that land on their base. The sample is going to be a sample of dropping 50, right? So we're going to try to drop 50. And then what is the statistic? That's the sample proportion. And to get that, we're going to call that P hat, right? The sample proportion. So you're going to go ahead and do this and kind of fill it out. Let me do one for you. I'm going to start with 10, 2, 4, 6, 8, 10. And what I'm going to do is I'm going to take 10 of them and I'm going to drop them, and count them. Okay, so here we go. Drop them and count them. I don't know if you can see this with me sharing, so I'm going to stop sharing. And there's my screen. I'll zoom out just a little bit. So here's what we got this time. Okay, here's my results. I ended up with 1, 2, 3, 4, 5 up and 5 over. So let me see if I have a pen. Give me just a second, I'll grab a pen. Okay. All right, so you can record your results. I ended up with 5 on the base the first time, and then we do it again, okay? And so we'd say, all right, here we go. How did I get this time? I got 1, 2, 3, just 3 standing up. So there's 3 standing up. And you're gonna have to do this 5 times because we want a sample of size 50. Okay, so here we go. 1, 2, 3, 4, 5. Okay. Oops, that one went off the table. 1, 2, 2. Okay, so last time. 1, 2, 3, 4, 5. Okay, and so now you can eat them, be fine. We ended up with, what is that, 10, 15, 20. So we ended up with 20 of them. We ended up with 20 of them out of 50. So our proportion, right, our sample proportion would be 20 out of 50 landed right up. 2/5 sounds like about 40%. So our sample proportion would be 40%. And we might actually then use that as a point estimate for all Hershey's Kisses to say, well, I don't know, if I dropped Hershey's Kisses all over the place, I would expect about 40% of them to land on their base. But now the rest of the activity is see if we can build a confidence interval for that. So back here on the handout, do I have a clean copy of that? Let me see if I printed one out. Yeah, here you go. So that way I don't have to share the screen. I can just put this over here. Right here under your results then, right here in your results, you're going to enter, right, 40%. Okay, and then we need to know, well, how did your group members do? So you're going to put theirs in here. Now to get your group members' results, you're going to post them, post what you got, and post and get your group members' results from the discussion board. So let me share again. Share the screen. Okay, so here we are back in the activity, and you can go over to the discussion board by clicking the link in the activity, or by going under discussions on the left here. Now, if I go to mine, it's going to look a little different than yours because I've got a bunch of discussions because mine's in teacher view. But you should have a discussion that says Hershey's Kiss Results Discussion Board. And if you click on it, okay, then you would get whatever your sample proportion was. Okay, so Jason's already ahead of us a little bit. Had his mic off, so we didn't hear him dropping his Hershey's Kisses, but he got 36%. Okay, so what you would do is hit reply, and then in your reply, it's going to put your name, so you don't have to put your name, but you could say sample proportion, and then you can say P, you know, it's technically P hat, but I don't know how to type a hat, so P equals, mine was 40%. So then you'd say post the reply. Okay, so mine was 40%. Jason's was 36. So I guess you'd be in good shape if you could get, you know, a few more people to post here so that you can use those results for the rest of the activity. So that's how the discussion board works. You're going to make 2 posts in this discussion board. One is going to be your sample proportion, right? And then later on, you're going to post your, I think your confidence interval at the very end. Yeah, your confidence interval. So I'm going to give you, the way I'm going to score this is if you posted twice, you get the 10 points. And then if you upload the results of your activity, then and you completed it, then you get the other 10 points. So it's just a regular 10-point homework assignment, and it should be pretty straightforward, right? So that's where we are so far. Okay. So I don't want to do any more of it and spoil it for you. You can go ahead and build your confidence interval. Then we're going to combine confidence intervals and see what happens if our sample size is bigger, right? We did samples of size 50, but if we combined 5 of you, then we'd have samples of size 250. And one of the questions is, well, what should happen to our estimate? Should it be better? Should it be worse? Should the confidence interval be wider or narrower? Should we be more confident if we did a bigger sample size or not? Okay, and so those are the kinds of questions that you're going to be answering at the end. And hopefully on the test too, and in the homework, because that's kind of the questions that we've been asking all along. Okay, so that is what I have for you. Questions about how to do the activity or post on the discussion board? Okay, not getting any. Then I think what I'm going to do is turn you loose and let you finish up this little activity. See if you can practice uploading a file to me. The way you upload this, your results from this activity will be the same way that you upload your supporting notes or calculations on your test. Okay, so that'll be good practice for that. And then you'll know that you can upload, upload a PDF to me, and that way I can score it for you and give you some partial credit on your test as well. Anything else I can tell you today? Okay, well, seeing no questions, I'm going to let you go. You guys have a great weekend. And if you get stuck as you're studying, getting ready for Tuesday, please let me know by email and I will help you get unstuck. Otherwise, I'm going to see you. I guess I will be available on Tuesday at 8:30. You officially don't have to be present on camera for this test. But if you're having trouble, I will be there. I will be online in the statistics Zoom meeting. So you can always join the meeting and then ask me kind of face-to-face some questions. But I need your test done sometime on Tuesday. And then we will kind of resume with chapter 7 when we get back on Thursday of next week. Okay, well, that's it for today. You guys have a great weekend, and we're going to see you guys either Tuesday or Thursday of next week.
All right, thank you.
Okay, you bet.
Thank you.
Mm-hmm. Kimberly, did you still have a question? I'm going to go ahead and sign off. If you have a question, you can come back for the other class at 10 or catch me during office hours. Okay, have a great weekend.